this program is using a chip to control the stepper motor. You can see the motor is reversing direction, so as pin 5 goes high and low, the direction changes. So with 5 high it goes anti-clockwise, with 5 low it goes clockwise. We can see in the program up here, symbol direct equals 5, so that is controlling the direction, and we can see down high direct, so the program will start off with 5 high and it goes anti-clockwise at the start. Okay, there's a low direct command here to make it go anti-clockwise. Okay. Yeah. So it starts off high direct, so that's making it go anti-clockwise, and then there's a loop for counter equals 1 to 48, high clock, pause 10, low clock, pause 10, next counter. So it does this 48 times. This equals 48 steps. 48 times 7.5 is 360. So it does one turn anti-clockwise to start with. Then does the direction then gets changed and does another 48 steps in the clockwise direction. Okay. Right, I've changed the program slightly so that the delays are half a second. Pause 500 and pause 500. Okay. You can now see at the start of the program pin 5 is high and we can see pin 4 pulsing on and off. Right? So it's the pulse of pin 4 that's causing the stepper motor to step. So pin 4 controls the stepping and pin 5 controls the direction. Okay, with 5 high this setup is going anti-clockwise, and with 5 low it goes clockwise. Okay, so by controlling the number of steps we can control the angle that the stepper motor rotates. So all you need to do is change the 48 to a different number to control the degree. Okay, so if it was 1 to 12, this would give a quarter rev. Okay. An advantage of using this system is by changing this number here, the 48, you can change the number of steps it takes. With the other system, the code was in blocks of 4, right? Let pins equal percent, zeros, 1100 or whatever it was. There was 4 of them. Okay, so you'd have to add on the extra bits on the end. With here, you just need to change that number. A stepper motor is used to control the position of something. With a stepper motor, you don't need to measure the output. If you give it a number of steps, you know that it's moved that number of steps times 7.5 degrees. So you should know the position of the output without actually having measured the output. Okay, so you don't need to have feedback with a stepper motor. That's its advantage. A disadvantage of stepper motors is that they use quite a lot of energy. Okay? And another advantage is when the position is locked as long as the power is switched on. Okay, that spindle will resist my trying to turn it while the motor is switched on.